više navrata smo radili s BIOS-om i Velom Mikletićem, toliko se hoću zahvaliti što je vas je sve pozvao i ugostio našu gošću. Neću puno pričati, jer je Marsha priča sama za sebe. Znači, danas smo doveli gospođu Marshu Ivins, umirovljenu astronautkinju NASA, koja je bila u 5 misija Space Shuttle. I ona će vam iz prve ruke ispričati sve svoje doživljaje, šta je radila. I molim vas, stvarno postavljate pitanja nakon predavanja, sve što niste saznali iz predavanja. U Zagrebu, u svim dječjim školama, gdje smo bili bilo zanimljivi svakakvih pitanja i stvarno poslije neću izgubiti. Marsha.
Thank you, and thank you for coming to spend your Saturday afternoon with me. I appreciate it. I'm going to tell you the story of human spaceflight, and I'm going to remind you up front that each one of the pictures that I show you was taken by a real person, including this one of the Earth. This is a real picture of the Earth, your planet Earth, taken by somebody at the moon. So how did we do that? Well, human spaceflight started in 1960 with a race between the United States and Russia to see who could be the first to put a man on the moon. The first person to fly in space was the Russian Yuri Gagarin. So in the United States, we were running a little bit behind that. This is the first capsule that we flew, the Mercury capsule. So you can see how small it is compared to the human beings. And the first American astronaut to orbit the Earth was John Glenn. The first rocket that he flew in had less power than a 747 airplane. So very small. And here's John Glenn from space. Before he flew, before anybody flew, the scientists, the doctors, the engineers were worried that your body would not work when you took it out of the Earth's atmosphere, took it out of gravity. So Mercury proved that in fact the body works just fine. At the end of the mission, the capsule landed in the water, and then the astronaut was picked up by the helicopter and brought back to land. So now we proved you could go to space and return safely, but before we would go to the moon, there were some other things we needed to learn. So Gemini was our second program. The Gemini capsule taught us 2 things. One was how to join 2 spacecraft together, traveling at 28,000 kilometers per hour, which is how fast you go around the Earth. And the other was how to do a spacewalk. When you go to space, there is no gravity, but when you are outside the spacecraft, there is no air. So all of the air and all of the pressure keeping him alive is in the suit, and it is provided in this case by this umbilical line that connects to the capsule. This is what it looked like inside Gemini. You can see there are 2 crew members. The longest flight was 14 days. So imagine living like that with the door closed for 14 days. In 1969, the Apollo program took people to the moon for the first time. There were 3 crew members in the Apollo capsule. One stayed in the capsule as it orbited the moon, and the other 2 went to the surface of the moon in the lunar lander. Remember, these are all real pictures. So those of you that think we did not go to the moon, we did go to the moon. This is the size of the lunar lander. There's the astronaut on the surface of the moon. This is the portion that was pressurized where the astronauts stood to land on the moon, and stood till they had no seat. So this stuff here is still left on the moon. That first landing on the moon, they spent 21 hours total on the moon. Their first spacewalk was a little over 2 hours, and they covered 250 meters. That was it. We then had 5 other missions taking astronauts to the moon. So we had 12 American astronauts who walked on the moon. And as we got more and more experience with that, we delivered a rover to the moon, and then they could travel up to 30 kilometers away from where the lander was. But 30 kilometers is not much when you consider the whole moon. And then that was it. Then we left. The Apollo capsule landed under parachutes, and it landed in the water. And then the helicopter picked the crew members back up and brought them back to land. And you can see how burned the capsule is from having come through the atmosphere. 1972 was the last time we were on the moon, and it is the last time anybody has watched the Earth rise or set from the moon. The Russians didn't make it to the moon, but they have been flying in space also since the 60s, and the vehicle that they fly is the Soyuz rocket. This is the way it looks today, and this is the way American astronauts now get to orbit. This is their capsule. So the crew members are in this portion here. Cargo and supplies are here, their engine and their solar array. And this is what they look like inside of it. And there are 3 of them inside. So not very much room inside that capsule. They also land under a parachute, but they land on the land. And they land in any kind of weather. So this was a landing about 4 weeks ago. And here's that capsule after the landing. You can see how burned it is from having come through the atmosphere. And this is the way the crew looks when they take them out of that capsule. So this was just a month ago. 2003, the Chinese demonstrated they could take people to space. Their rocket looks very much like the Soyuz rocket. Inside, it looks very much like the Soyuz capsule. They have done their first spacewalk. They have their own single module space station. They have flown 2 women now in space. They also land under a parachute. And here they are after their landing. It's very much like the Russian system. All these capsules were used only one time. They are so damaged coming through the atmosphere that they could not be used again. In 1981, we started to fly the space shuttle. The shuttle was designed to come back through the atmosphere and not be burned. So the material that covers it sheds the heat so it isn't burned, so you can reuse that vehicle again. It launched like a rocket. It flew in space like any other capsule, and then it came back and landed on a runway like an airplane, but with no engines, no air-breathing engines. And this is what I flew to space 5 times. You might think that being an astronaut is a very glamorous job. I remind people this is the last view anybody sees of you before you get into the capsule. So this is me here, decked down in enough equipment that it doubled my own weight. And that's the way we launched and landed in the space shuttle. We did a number of things with the space shuttle over its 30-year history. We took a lot of satellites and payloads to orbit. We took the Hubble telescope to orbit. And for the last 10 years and 35 missions, we constructed the International Space Station 1 module at a time. So the modules were carried in the back of the cargo bay, and then we will attach the shuttle to the space station. So here were the first 2 modules of the space station, a US module and a Russian module. And then we will attach the shuttle right to that place. Using the robot arm on the inside, pick that module up from inside the cargo bay, rotate it around, and attach it to the place on the space station where it is connected. So over the years, the space station continued to grow as we added parts. We added solar arrays and mechanical arms. We added modules from the European Space Agency and from the Japanese Space Agency. And a couple of Russian modules were added, more solar arrays, and this is the way the space station looks today. This is a real picture shot by a Soyuz backing away to take a picture of the space station at the time with the shuttle attached. At the end of its mission, cargo bay would be empty and the shuttle would come home. At the end of the construction period for the International Space Station, the shuttle made its last landing in 2011. So that's what the vehicles look like. Here's what it's like to be inside. Now remember, there's no gravity. That's me. In case you're wondering how that picture was taken. So that's just done for the picture, otherwise things would collect in my hair. Here's what it's like to live without any gravity. Without gravity, there is no up. Each one of these crew members thinks they are pointed up. When the shuttle was attached to the space station, we could have 10 crew members on board. Today, there are only 6, and these are the 6 people that are currently on board the space station. So we have 3 Russians, we have a woman from the Italian Space Agency, and we have 2 Americans. This is the guy you might read about who's going to spend a year in space, with this guy right here. I think it's this guy. And he, right now, is the commander of the space station. And I told him I was coming to Croatia, so he's taking pictures, which I will show you, that were taken just a couple weeks ago. When they come home, when they launch and they land in the Soyuz capsule, this is what they are wearing. Without any gravity, you can hold up a very heavy weight with a single finger. And without any gravity, you cannot walk, you must fly. Now you notice you never see them stopping, because when I push off from someplace and I head to where I'm going, I then stop by crashing into the wall. So we know why Superman flies with his arms out in front of him. When you're flying, you can do some very interesting things just by moving your body a little bit. That's me in the background here. Now, you may be scientists and you know that for every force there is an equal and opposite force. Imagine that you are floating and you're hit by a very heavy object. So here's me. Now I'm not moving from one place to another, I'm just staying stationary. But just by wiggling my hips, I can do a complete turn. Here is the demonstration of the ice skater. And without any gravity, you can spin all day long and never get dizzy. So as he spins, with his arms open, he slows down. When his arms close, he spins back up again. Here is conservation of angular momentum. Now he's going to try to do the same thing that I did. He can't do it as well. Guys don't have the same hip action. Here is one crew member using another crew member like a surfboard. So you've seen people floating around. What if you want to stay in one place while you're doing work? If you're typing at a keyboard, for example, and I type a key, I would float away from the keyboard. So we have these straps that are mounted all around the space station right now, so you can slide your toes in and stay in one position. There's one that didn't show up. This is a ball of water. And in the absence of gravity, surface tension is the strongest force there, and it holds the ball of water together. This is orange juice, just much more photogenic. So here's how you make that ball of water. Water is in the bag. He squeezes the bag, and it comes out through the straw. That's a straw there. And these guys are going to make a really big ball of water. See little balls of water just break off from it. Now that they have this really big ball of water, they're going to throw a GoPro camera into the ball of water. And now he's going to turn it on. A waterproof GoPro camera, of course. And so here's the picture from inside the ball of water. Now look at the water on his hands. That's the way surface tension just holds the water onto your body like that. So keep that in mind, because that's how we're going to take a bath. These drink bags, if you don't want plain water in them, you find a drink bag that has powder in it that will be the drink you want to drink. Tea, coffee, juice, various other things. And you fill that bag up with a water dispenser in the wall. Sometimes the crew likes to drink directly from the water dispenser. Now our Italian crew member, they just sent her an espresso machine. So she has her own little bags of espresso here. In fact, they sent her a little cup that's a very uniquely shaped cup. That if you shape a cup just right, the surface tension of the liquid on that material will allow it to sort of wick up the material, and now you don't need a straw. So they fashioned this very complex shaped cup so that the crew can drink their espresso now in their morning window without a straw. There is no oven and there is no refrigerator, so the food has been cooked already and it's been freeze-dried and vacuum packed. It's been put in these little packages. Now you have to put the water back in it, and that's done with a hydration station. You plug the package in and you push the button for room temperature water or hot water, and it fills it up. Then you put it in a little heating device that warms it back up again. Other food comes in packages that have the liquid already contained, and then they've been irradiated so that they don't have to be refrigerated. On board the shuttle, You can see his feet are in those straps, a tray tied around his leg. Each food package is stuck to a piece of Velcro. He's eating one with a spoon. And his drink bag sits right out in front of him, so when he's ready, he can just put his mouth on the straw. On board the station, there's a table with a bar underneath where you can hook your toes, and then straps hold the food packages down to the table. You can see the long spoons that they're using to eat, and these plastic bottles in the back hold the liquid salt and the liquid pepper and the liquid spices. Because everything is floating, well, first of all, we don't use a knife and a fork because there's no way to keep the food on the plate cut with a knife and a fork. But you want food that makes no crumbs, no bits. So here's one of the perfect space foods, peanut butter and honey. And here's peanut butter and honey on a piece of bread. The Americans provide half of the food, the Russians provide half of the food. So here's the Russian food. Doesn't that look yummy? For example, jellied beef tongue. Who eats that? But again, who eats some of the American food? This is the cream and spinach. Here is one of the meat products. So it's been cooked already in the package. The juice is in it. You warm it up and you cut off the top. There's your scissors. And then you sort of eat it like a popsicle. You chew on it, and then you push it up some more and chew on it some more. And that's the salt dispenser. Or you can be creative with it. So here, we've taken a tortilla, clipped off to the wall with a Velcro clip, with mustard and ketchup, and that will just hold the meat onto the tortilla. So the crew has gotten very creative with this. Here is the tortilla floating with the meat. This is squeezed cheese, cheese from a tube, and chili paste. Or the breakfast version of that is sausage with eggs and grits. So it's not a five-star dining in space. Sometimes the crew uses the chopsticks, because the chopsticks are a little cleaner than using a big, long spoon. But without any gravity, you can hold something the size of a grapefruit with your chopsticks. Speaking of grapefruit, when you want a piece of fruit or a vegetable here on the Earth, you just get it. I mean, it's accessible anytime. But when you are in space, and a cargo vehicle only brings you supplies every 3 or 4 months, then having fresh food and fresh fruit and vegetables is a luxury. So every time we send cargo to the space station, we send them fresh food, fruit and vegetables. Sometimes you just want to smell the fruit before you eat it. Here is your space M&Ms. Okay, there goes the cream spinach. See, nobody wants to talk. There's a shrimp rotating on a fork there. Here's the M&Ms. And here's throwing M&Ms into a ball of rice. Here's a bag of pistachios. So typical man sees food, opens mouth, grabs food. She's a little bit more ladylike as she has her pistachios. Here she's making the ball of orange juice. So she squeezes the bag, the ball comes out the top of the straw, then she'll yank down on the bag, and that will separate it, but the surface tension holds it together, and now he's moving it around with a piece of dental floss. This is the NASA high-tech trash compactor. What do we do with the trash? We don't throw our trash into space. Nobody comes to collect the trash. So you collect your trash yourself in a bag and compress it so that it doesn't take up a lot of room. On the space shuttle, we brought all the trash home. On space station, they collect the trash, and then they wait 3 or 4 months for the cargo vehicle to show up, offload all of the good cargo, fill it up with trash, send it home to be burned up. So you have to be very careful in how you manage your trash. Here is your tool chest. So you can see there's a rack down here that has all these drawers in them, and each one has foam cutouts where each individual tool fits into those cutouts. Exercise. If you do no exercise here on the Earth, the fact that you stand up, that you walked up the stairs, does exercise on your body, because everything you do, you are working against gravity. when you go to space and there is no gravity, your body is very happy to not have to work that hard. Now when you come back to Earth and gravity is on you again, now your heart could be weak, blood could have a hard time moving around, your muscles could be weak. So we exercise 2 hours every day on the space station. One way is on this bicycle ergometer. He has a belt that holds him onto the platform. Then his shoes are clipped into the pedals, and then he can pedal against a resistance. We also have a treadmill that's bolted into the floor, and then she wears a harness that holds her down onto the treadmill so that she can run. And then we have a resistive exercise device that will let you do the same kind of exercises that you can do in a gym. So he's doing a bench press, but you can do squats and you can do curls. And so 2 hours every day they spend on a combination of all of these exercises. Sometimes the crew has their own sporting events. Here is a soccer game that happened during the World Cup. You can see there, this is why they are not soccer players. Although this is a pretty good goal here. You see somebody running on the treadmill in the back. And then here's a motion I don't think you see in soccer games. I think they call a foul on that one. The crew can bring their own music and their own books. We used to actually bring real books. Now everybody works with a laptop and e-readers. There are a couple instruments on board. There's guitar. Guitar without gravity is easy to play because you hold on to it, as is the flute. That's her own personal flute. The keyboard is strapped to a bag operated by a battery, so you can play that. And a crew member who's going to launch in about a month claims he's going to bring bagpipes. It'll be really thrilling for everybody. These laptop computers are used now to do all the checklists and all the procedures. So we've gone to a paperless environment on board the space station for the most part. You can get email from home. You can get the news. You can get sporting events. So he's watching soccer right here. You can get movies, so it's very good. And then you can use it as a telephone. So it brings up the numbers on a phone. You push 9 for an outside line. And then you can dial anywhere in the world. So there are 6 phone lines on board the space station, and they can call their families anytime. And it sounds like they're right next to you. It's really a great system. Here's how you take a bath. There is no shower, there is no bathtub, because water won't run. Water forms a big ball. Remember the water on his hand? Well, you put the water on you. Just put on a ball of water, spread it around, take a washcloth with soap and soap yourself. Put on another ball of water, spread that around, and then take your towel, which is about that big, and dry yourself. So you do one section, and then you do one section, and then you do one section. You do it. So it takes quite a while to take a proper bath. Shaving is normal. We have electric razors, battery razors, and straight razors. When the men started flying for longer than a couple of weeks, they wanted a haircut. Think about how you cut hair when there is no gravity. Well, this device cuts hair and sucks it into this vacuum cleaner hose. Now normally, to date, it has only been the men that have had a haircut, but she wanted her hair to be cut. So she took him to her hairdresser and made him learn how to cut hair. So he's very good at it, actually. She's holding the vacuum cleaner hose. He's cut her hair 2 or 3 times, and he's cut all the men's hair. So he has a second career coming, I can see. Not everybody cuts their hair, of course. Here is toothpaste. You get toothpaste and a toothbrush. Normally, you brush your teeth, but there's no place to spit. So they tell you should swallow the toothpaste. Wait, who swallows the toothpaste in here? Anybody? Great. This is how we slept on board the space shuttle. You took a sleeping bag and you tied it off to the ceiling or the floor or the wall, and then you got in and you zip it up, and you take those blue straps, which are Velcro, and you tighten them, and it makes you feel like you're tucked in. And whatever you don't tuck in just sits there and floats. But your hand doesn't fall asleep because there's no gravity that takes the blood out of your arm. It just feels kind of funny, and sometimes you wake up in the morning and see a hand floating out there in front of you. You put your head on the pillow, which is a block of foam, and then you strap your head to it. Sounds a little strange, but think about it. When you go to sleep at night, on your side, your back, or your stomach, and you put your head down, your neck is at rest. And if your neck is at rest, the rest of you can be at rest. So strapping your head down makes your neck at rest, and you go right to sleep. On board the space station, each crew member has their own compartment to sleep in. In the compartment is the sleeping bag. So she's tucked in, she's got her arms all tucked in there. And then she has a drink bag, and she's got some checklist and some various other things. Her computer will be in there, and that's how you sleep. So no astronauts can be claustrophobic. Here is the toilet. So Russian system, but here's how it works. This hose, you pull this hose down from the wall, you slide your toes underneath of this so that you don't float away, and you hold the hose in the same position for boys and girls. Everybody uses the same one. And when you start liquid coming out of your body, you turn it on and it sucks the liquid down the tube to collect in a tank behind the wall. After it's been collected, it is then reprocessed back into drinking water. Or as the crew says, making tomorrow's coffee out of today's coffee. When the shuttle used to fly, we would bring the space station 1,000 pounds of water. Now that the space shuttle doesn't fly, how do you provide fresh water for the crew? So we recycle now all of the water, all of our wastewater, both from the body and from humidity and condensation. We reprocess it back into water that you can drink and rehydrate food with, and that you can break down into oxygen and hydrogen. So we also resupply our own oxygen. These are Russian systems, and they work really well. Okay, to collect solid waste from your body, you open the lid and you put a bag here in the can, close the lid, and then you hold yourself on the seat, because you would not want to float off the seat. Okay. You do what you're doing in the seat there. And then there are wipes and tissues, and you can clean up everything. Put it in the bag, close the bag, put in a new bag for the next person. And when that can is full of bags, you replace that can, put the lid on it, put a new can in, and the can will wait 3 or 4 months for the cargo vehicle to show up. So no one has ever complained. It does not smell bad on board the space station. Some parts of the space station look like you might think a space station looks. This is the Japanese module. Lots of equipment, and this is a little airlock for experiments to go outside. This is another module. This is one of the US modules. We now have so many experiments and so much equipment that it looks very messy and busy on the inside. And the crew spends a fair amount of time doing maintenance, and when they do, they get surrounded by cables and wires. All of our supplies come up in these big white bags, and so there are white bags everywhere. Sometimes you even lose the crew. Science on board space station is looking at what happens to different processes, materials, chemical, biological, when there is no gravity. So we have a furnace to study materials. We can study certain chemical experiments. We have a glove box where you can work with small objects or biological things. We have a very cold freezer that will let you store the samples of your experiment before you can bring them home. We had a crew member one day decided that he wanted to grow a zucchini plant. So he put a seed in a bag and he watered it, he fed it, made his own little mulch out of coffee grounds and various other stuff, and out grew the zucchini plant. And without any gravity, it can grow a very long stem because it doesn't have to hold up its whole plant. In fact, without any gravity, a leaf can hold up its own ball of water. And most of the time, we are the experiment. Understanding how the body behaves without any gravity is very important if we want to spend longer and longer periods of time in space. So as she exercises, they're measuring her respiration. Here she's doing an echocardiogram of the heart. We have some astronauts who are doctors, but not always is there a doctor on a mission. So the crew learns to do doctoring on each other, so they can take each other's blood And here studying the pressure inside of the eye. Occasionally, the crew on board the space station does a spacewalk in order to repair things on the outside or replace equipment on the outside. So 2 crew members get into their spacesuits, and here they are outside. Remember, all of his air and all of his pressure is inside the suit. He's got a safety line that connects him to the structure. And you never go anywhere without connecting your safety line. Because we knew we would have crew members moving around on the outside of the space station, we put these big gold handrails in so that the crew member can go hand over hand, moving himself along no matter how large the vehicle gets. So here they're all the way out at the end of one, and you can see the safety lines still connected. That mechanical arm can also be used to move an astronaut with a piece of equipment to a workstation where his feet are supported, and now he can work with 2 hands. So what happens if he comes out of that restraint on the robot arm, or his safety line breaks? He is wearing a little backpack that will let him fly back to the space station to hold on or to rescue his partner. Unlike George Clooney in Gravity, he cannot go that fast or make turns that sharp or zoom around or go to another space station. But he has a little bit of a maneuver. Here is the ultimate space selfie. So here is the camera lens, here's his arms, so he's holding the camera out here, taking a picture of himself, taking a picture of himself. And sometimes the crew just wants to play. Notice the hard part is getting your feet disconnected from the straps there. See, he cheated, he had one already out. This part of the space station is all windows, so it's a great place to watch the Earth go by, literally, and a great place to also take pictures of the Earth. Remember that first picture of the Earth that I showed you? Well, that was taken at the moon, and the moon is 400,000 kilometers away from the Earth. Where we fly in a space station is at 400 kilometers. So this is the view of the Earth that we see from the space station that I saw from the space shuttle. Some parts of the Earth look unusual, like the glaciers in the Andes. This is ice in Newfoundland. This is the waters of the Caribbean. This is in the Himalaya Mountains. These are mountains in China. These are sand dunes in Algiers. And this is the Namibian desert and the west coast of Africa. You could look at these pictures and convince yourself that the Earth was uninhabited until you see it at night. So here's the picture of Croatia that our station commander took for you a couple weeks ago. Well, you're in there, right? Because our Italian crew member has been shooting Italy pretty much non-stop, I said, you know, lean a little right. There you are. So there's the coast of Croatia, and here's that same picture at night. So there's Zagreb right there. You want me to go back one? Okay. So here's another picture of Italy. And this is a real picture. These are very cool. So here's another one that he took. They're much better when the lights are very dark. So you have a great coast, which you know. So that's why people take pictures of it. Here's looking more to the south. So here's the Greek islands here, and there's Italy right there. The solar array and one of the Soyuz and Progress vehicles attached. There. There, you are here. So we put a line in for where you are. And here's a nice close-up. Is there an airport? Oh, no, this is Zagreb. Right? Actually, do you have an airport here?
Yes.
Okay, then this is you. There's your airport. That's right. And here's their airport. Airports are very recognizable. We tend to take pictures of airports. Other parts of the world that are recognizable, the Strait of Gibraltar, the Sinai Peninsula, Florida in the United States, New York City, New York at night. Washington, D.C., cities all tend to look sort of, you know, like a blob together like that. San Francisco, and looking very much like San Francisco, there's Venice. People always ask about Las Vegas, so there's Las Vegas, right? It's pretty dull and boring, of course, until you see it at night. There's Las Vegas at night. And here's Paris at night. Here's Moscow in the snow. Here is Tokyo Bay. So it's recognizable by the way the bay is chopped up like that. And here it is at night. And I think that's the brightest part of the Earth. The Great Barrier Reef, Hawaiian Islands. A very rare picture of both islands of New Zealand not covered by clouds. Here's the Mississippi River in the United States, and here's a close-up of that. And if you might remember the big oil spill, here's the Mississippi River, and this was the BP oil spill. So very recognizable from space. Here is the Brahmaputra River and the Ganges Delta. This is the Danube. And of course the Nile. And here is the Nile at night. We go around the Earth once every 90 minutes. And every astronaut from every country who has flown has come back and said the same thing. As you go around the Earth every 90 minutes, you do not see borders that separate the countries. We learn borders when we learn geography. Each country is a different color. Each city is a different color. Well, they're not. You see one complete Earth, no natural borders. Sadly, what you do see is man-made borders. This is the lighted border between India and Pakistan. Other man-made objects that you can see, these are the pyramids, shadows from the pyramids. This picture at night, this is China, right here, and this is South Korea, and that is North Korea. Next time you hear the news, think about this picture. These are fishing boats near Bangkok. All these legs here are fishing boats. And here are fishing boats in the Sea of Japan. This is the Grand Canyon in the United States. The Himalaya Mountains. Mount Everest. Mount Etna. And Mount Fuji. This I thought was really interesting. I saw this picture. This is actually on Crete, and this is an airport, but it looks like a US dollar sign, which is, I'm sure, why the crew shot it, because interesting. So we like interesting patterns. Here is looking at airplane contrails from above, looking down on them. These are rice fields in China in the snow, all nice and lined up. But here in Brazil are irrigation areas where they irrigate an area that is in a circle from the center, center pivot irrigation. The green ones is where something is growing, and the less green ones, or the brown ones, is where that land is fallow at the moment. These you see all over the United States and South America, and you also now see them all over Saudi Arabia. They are using fossil, each one of these dots is one of those round areas. They're using fossil water from the center of the Earth. So when the water has been used up, there's the lighter color ones, they just move over to another area. And over 30 or 40 years, we've just seen these things spread out in Saudi Arabia. Here is just north of you, and here's the Danube, but you see the agriculture here is all straight lines, not rounded. Here are patterns in the clouds. A very distinctive pattern in the cloud known as a hurricane. And here's looking right down the eye of a cyclone. And here's one of them as they dissipate. So what you see on the Weather Channel at night really looks like that. Here is a thunderstorm. And here is lightning. All those white flashes are lightning. You see this green line across the top here? That is the top of the atmosphere. So all the air that we breathe is below that line. And on space station, we're flying about that far above the Earth. So we're not very far. Said we went around the Earth once every 90 minutes, so 16 times a day we see the sunrise and the sunset. So we fly for 45 minutes in daylight, and then there's 45 minutes at night. And that line that separates daylight from night, we call the terminator. I had a kid laugh the other day, it's not that terminator, it's the real terminator line. But 16 times a day, we get to see the sunset and the sunrise, and they are spectacular. That's a little sliver moon right there. Also, we see the northern and the southern lights, the aurora. So there it is in motion, and you see the aurora glowing right at the top of that atmosphere line. In the southern hemisphere, you see it shooting up above you, so it feels like you're sort of being surrounded by it. And here is the Milky Way rising. So this is what you can see. More stars you can see outside of the atmosphere than you can see here on the Earth. So that's the International Space Station, and we'll continue to fly the International Space Station for at least another 5 years or so. And this is what we do today. What do we do in the future? Well, now that's a good question. For 50 years, we have been in orbit around our one planet, using the same technology that we used 50 years ago. When is that true anywhere else? Not in cars or boats or airplanes or any technology that is developed. When does the technology not change every day as you continue to use it? Well, human spaceflight. That's when it does. We went to the moon once, but we never really explored the moon or learned to operate away from the Earth. It only takes 3 days to get to the moon, and only 3 days to get back. So we went to the moon. If something broke, we could come home. We went to the moon, we picked up a rock, we came home. But what if we could learn to actually live away from the Earth, to make our own fuel, to make our own water, make our own oxygen, repair our own hardware? Then we wouldn't have to just see Earth close on the horizon. We could go to some place like Mars. Real picture of Mars. Mars takes 6 months to get to. Then you have to wait 18 months till it only takes 6 months to come back, because the distance between the Earth and Mars changes every 22 months. There's closers and there's far away. So you launch on Earth to get to Mars when it will be as close to you as it can possibly be. So Mars is a 3-year mission. And if something goes wrong, you can't just turn around and come home. Now there's a project out there, Mars One, that says we're going to go colonize Mars. Right? Anybody sign up for that? Yeah, don't tell me you did not. Well, then let me tell you about that. This is the perfect slide, which didn't show up. The largest thing that we are capable of putting on Mars is the Curiosity rover. It's the size of a smart car. That's as big a thing as we can put on Mars. It's been estimated that in order to support living and colonizing Mars, each vehicle needs to weigh what the International Space Station weighs. And it took us 10 years to build that. So until someone figures out how to get that much mass onto the surface of the planet, including the mass of you, and everything it needs to provide you, we are not colonizing Mars. Well, Mars actually could be colonized. Mars has gravity. It has 1/3 of the gravity of Earth, so you feel like Superman a little bit. It has an atmosphere that's made of carbon dioxide. You mix carbon dioxide with hydrogen, you get methane. Methane's a fuel. Now if you have fuel, now you can do a lot of things. It's farther away from the sun, but not so far away that solar power would not work. But you can provide yourself electricity, and you have fuel. Now, and there's water. So you could make water, you could make oxygen, and we really could learn to live on Mars. But that's about as far as we can get with today's technology. Because like I said, it takes 6 months to get to Mars. It would take years to get to the other planets and the moons of our planets in our solar system. 37 years ago, we launched a probe called Voyager, heading for the edge of the solar system. 37 years later, it's not there yet. So with our technology that we have been using for the last 50 years, exploring much beyond Mars is not within our capability. But one day, when we learn how to do that, then we can explore the other planets and our own galaxy. Out of our solar system, into our galaxy, and into other galaxies. These are pictures from the Hubble telescope showing other galaxies. Now you can do a real Star Trek thing, and now this would be very cool to do, seeing galaxies interact with each other. Stars that are dying, and nebula where new stars are being born. That's the best picture. All right. Imagine that picture from the Hubble telescope that shows a zillion little dots of light. Have you seen that one? You know which one I'm talking about? That picture covers the part of the sky covered by your thumb. So that zillion little dots of light covers a little tiny part of sky. And each one of those dots is not a star. Each one is a galaxy. A galaxy, billions of galaxies surrounding us, each with billions of stars, each having in the galaxies billions of planets. People say, why would you go to space? Why would you leave the Earth and explore space? And when I look at that picture, which I cannot show you, when I look at that picture, I think, how can we possibly stay home? Thank you. That I have not already answered. I normally get the big ones covered.
How did you feel the first time when you went up to space, and what was the most unpleasant experience when you were up there?
Many people feel sick when they initially get to space. I was very lucky that I did not feel sick. So that would have been the most unpleasant experience. And the rest of it was just amazing. When you get in an airplane, or you know somebody that gets in an airplane, you don't think it's a really big deal. Everybody gets in airplanes and flies places. Not a lot of people get in spacecraft and leave the planet. And so I had been training, I had been concentrating, I get to orbit, and I'm concentrating on what I have to do next. And the little voice in the back says, "You left the planet." And there's no way to describe that feeling.
How long does it take to readjust the conditions on Earth when you get back from the mission?
How long does it take? Well, my missions were 10 days or 2 weeks. So it would take me a few days to get feeling Earth-like again. The guys that spend 6 months, it takes them about a month or longer, and they are very precisely monitored. They have a person that works with them. They're not allowed to drive for a couple weeks. They're not allowed to lift heavy objects. They're not allowed to run on the street. They run in a water treadmill in a swimming pool. They do a lot of balance exercises with them. Because when you come back, your inner ear, the thing that keeps you balanced, is based on a gravity system. So you can demonstrate that just by standing with your eyes closed. And as you stand there, your body will start to lean, and it will correct itself, unless you've got a cold or something. Because in your inner ear, like a little 3-axis gyro, it senses you've leaned, you know, pitch, roll, and yaw. It senses that, and it corrects your body, because it knows where gravity is. Now you take gravity away. Well, that helps you do other things, like when you sit down on the seat. How do you know where the chair is? You ever think about that? I mean, what sensors are back here that tell you that's where the chair is? When you walk, how do you know how far to pick up your foot? All of this stuff your body has learned. It's called proprioception. It's learned because you are working against gravity. Now take gravity out of that. And that system just goes to sleep because you don't need it. Now you come back to Earth, and it's really sensitive. So I come back, if I move my head very fast, I will fall over. When I go to sit down on the chair, I crash into the chair. And I'm not really sure how far to pick my leg up, so I have to pick my leg up like this, and then I have to walk holding onto the wall. And if I want to turn, I have to keep my head very steady, and I have to turn like this. So if I'm talking to you, I'll, turn back and forth. It's really, it's like being drunk without drinking.
I have one question, and it is more of a personal related one than an astronaut related one. Do you personally believe in extraterrestrial life, and what do you think about the possibility of one day discovering it, and what doors can it open for humanity?
I look at that picture that I can't show you that shows all those billions and billions of galaxies, and I think it's not possible we are the only life. It can't be an accident that we are the only life. But the scale of those galaxies, when you consider light years away and billions of light years, I mean, those are numbers that we can't wrap our brains around. There's got to be life somewhere. In our neighborhood of the galaxy, maybe we're in the country. We're in a low density population part of the galaxy, so I don't know. Do you read science fiction? All right, so the science fiction writers go wild with this question, and most of them assume that alien life is here to eat us, or destroy us, or created us and is wiping it out because it's an experiment that failed. I mean, those are great concepts, and I'm good with all of them. I mean, I think there has to be life somewhere, and whether we find it or it finds us, it alters the way humanity thinks about itself, because we have a very selfish way of seeing life. We are it. I am it. Well, we're not. We're not even close to it. But proving that will, I think, affect a lot of people in different ways. I hope I live to see it.
Do you see now the planet like some form of life by itself, like Earth? Is it a system by itself? Can you see that everything is connected, and do you better understand the Earth and the cycles of it when you see it from far away?
When you study in school, I mean, you're taught that the Earth is its own environment, and something that happens in one country affects other countries. When a volcano erupts, that ash is carried by the winds and eventually circles the entire planet. When in South America, rainforest was being burned, the smoke was carried all the way up into Northern America and into Canada, and you could see that in photographs where the atmosphere just looked dirty. So you know that this is a fact when you study science and you study geography and you study things like that, but you can actually see some of it. And it's the same of the extraterrestrial life. Proof is what convinces you that, no kidding, the books are correct. So yeah, you do become a little bit more aware of the environment as a whole.
And what are the prerequisites for becoming an astronaut, and how long does the whole process last?
All astronauts in all countries right now have a technical degree. So they all have a university degree in math, physics, science, medicine. Most astronauts have advanced degrees, a master's or a PhD. I do not. I just have an undergraduate degree. Quite a few of our astronauts, and the ones in the United States and also from other countries, have been military pilots. And they are been selected from that group because they've demonstrated that they can maintain their cool in a stressful environment. So many of them are civilian pilots. I'm a civilian pilot. Selection is done in each country in a different way. In China, all the astronauts are military because their program is sort of protected. Even the women are military. In the United States, probably 50-50 military and civilian, academic, engineers, doctors, that kind of thing. The only way to become an astronaut is to be selected by a country who is participating in a space program. So the European Space Agency, its partner nations all bring their astronauts together, and then they are trained in the United States and Russia. So first step is a technical degree. Second step is to find a country or find a program that will accept you. Most people, when they apply, don't get accepted on their first application. I was accepted on my 3rd application. So then you keep trying and keep trying. A lot of our military astronauts were not selected by their military service, but they applied through the civilian route and were selected that way. So we keep banging at the door.
You mentioned that you were on 5 missions, right? Can you be a little bit more specific what you were doing with the first one, what you were doing with the 5th one? Like, was it always one mission?
My first mission, which is in 1990, we put a satellite in orbit, and then we brought home a satellite that had been in orbit for 6 years. It was studying the effect of cosmic radiation and ultraviolet light on different materials like paint and wires and things to teach people how to build satellites to spend a long time in space. And we had to fly up next to it, we had to grab it out of space with a robot arm, put it in the cargo bay, and bring it home. On that flight, I was the flight engineer, so I helped during the launch and the landing with helping maintain situational awareness and keeping everybody on the right page of the checklist. And then I did a lot of the photography, I did a lot of the science work, and everybody puts experiments on board. We're never the scientist. We are the operators. So the scientist teaches us how to work the little thing that we've been flying and then begs us not to break it. And so we do that. On the second flight, it was a science mission demonstrating a deployable tether. So the tether flight was very interesting. The physics principle behind that says that if you take a mass on a long conductive material and move it quickly through a magnetic field, you generate electricity. So we're moving at 28,000 kilometers around the Earth. We strung out 20 miles of copper wire and moved it through the Earth's magnetic field. And so it would generate electricity. Well, it didn't work. It worked, but it only got out about, a 1/10 of the way, and then the cable snagged. So we had to stop and do the whole Apollo 13 thing and, do the maintenance and bring it back. So that was my second flight. We also deployed a satellite on that flight. My third flight was a materials science experiment that was in the cargo bay. So we turned it on, and it did its thing, turned it off at the end of it, and we had a number of little experiments on board. And I was a flight engineer on the second flight. On my fourth flight, and I did some robotic arm on that third flight also. My fourth flight, we went to the Mir space station, which was the Russian space station that's no longer in orbit. And we took 2,000 or 3,000 pounds of cargo and a crew member. So my job was to transfer all of that stuff onto the Mir and then bring all of the stuff we were bringing back, get it all packed up in the right bag. So I was the load master. On my last flight, we went to the International Space Station, and we were a construction flight. So we took up the US laboratory module. And it was my job to use the robot arm and take that thing out of the cargo bay and stick it onto the space station. Hardest thing I've ever done. Scariest thing I've ever done. And then I was the load master. So then I had to get all the stuff in there and all the stuff back out again. And I was the flight engineer for that flight also. So each flight is a little bit different.
You said you had an Italian girl and 2 Russians and 2 Americans right now.
Mm-hmm.
What time zone do they use to coordinate?
They're actually they're in GMT. So that's where we are, right?
No.
You're 1 hour off?
We are +1.
Oh, +1. All right, so they're 0. That's where their time is.
So you said the last manned mission to the moon was in the 70s, right?
Mm-hmm.
Why is that?
Yeah, good question. Sadly, space programs right now, because they are so expensive, are funded by governments. Everybody's space program around the world is funded by the government. And the government, is run by politicians. And politicians, have their own agenda on what they want to do and what they want to spend money on. And we had done 6 flights that were very successful. We had 3 ship sets of hardware built. So we had 3 Saturn V rockets, we had 3 Apollo capsules, we had 3 lunar landers, and the president at the time, President Nixon, canceled the program because it had been President Kennedy's. That's it. Now, they tell the story it was expensive and we couldn't sustain it, but that was not the case. It was one president saying, well, everybody likes that, but that was his, and so we're going to cancel it. And that happens in every country's space program, sadly.
How do you keep ISS free from bacteria?
From bacteria?
Yeah.
Well, you don't. You try very hard to not make a mess, to clean up after yourself. When you bathe, when you eat, you try to keep everything clean. And it's always a problem.
Would you pop like a balloon if you were to exit the station without the suit?
Yes. Yes, I mean, it wouldn't be as nice as a balloon popping. Your body is a closed system, right? And it's a closed system under a certain pressure. It's the local pressure here, so you're at a sea level pressure right now. If I take you to a higher pressure, you feel your ears popping, right? And that's because air is trying to get out, and your ears are constructed to allow that to happen. When you come back to a lower pressure, you know, you have to pop your ears in order to do that. Well, that's just a tiny little bit of pressure. If I took you immediately to zero, all the gas and all the fluid in your body would want to get out of your body, and it would find a way to do that. So where's the easiest way to do that? Out of your eyes and your nose. And yeah, it would be a very messy balloon popping. Don't do that.
How difficult is it to endure the G-forces when you're taking off the Earth and going down?
What is the G-force?
Yeah, and how difficult is it to endure?
The space shuttle was actually very gentle by comparison to the rockets, because the space shuttle had wings. We couldn't put a lot of G-force on it. So the ascent trajectory was shaped so that you really went downrange a long time to pick up speed as opposed to going more straight up. So we experienced 3 times our weight on the ascent. The guys that fly in the Soyuz capsule experienced maybe 4 times their weight. Now, it's weight that's going, the force is going this way. So it's like a gorilla is sitting on your chest. Imagine a gorilla sitting on your chest. It's really easy to exhale. Then it's really hard to inhale. You have to inhale and push the gorilla back off your chest again. So the first time I flew, and I had 3 times my weight on me, I thought, oh no, this is interesting. I've exhaled now, how am I planning on inhaling again? So, you know, I did like that for a while, but you get used to it. Coming back on the shuttle, again, because it has a wing on it and it can't sustain a very high load, we only very gradually came up to about 1.5 times our weight. When you come back in a capsule, it just comes in. So they're getting 4 or 5 and occasionally 8 times their weight. And again, it's the gorilla kind of thing. It's not this kind of weight, it's the gorilla. But that hurts. 8 hurts. 5 hurts. 4 hurts now that I'm old. And so you just get used to it. They do train astronauts now. I didn't get the training, but they put them in a centrifuge and spin them up so that they can experience that kind of force. When you fly in an airplane and you pull a lot of G's in an airplane, it's down. It's a different kind of vector. So do that in the centrifuge.
What do you think about Elon Musk, SpaceX, and Mars stuff?
I'm sorry, say that again?
What do you think about SpaceX project, about Mars?
Elon Musk and SpaceX.
Oh, Elon Musk is, all right. So Elon Musk, SpaceX, is a commercial spacecraft, or commercial company. I went to space with commercial companies. All our hardware was built by Boeing and Lockheed and Pratt Whitney and Northrop Grumman, but it was built to a specification laid out by the government that said, here's what I want to do. I want to be able to fly this much cargo, and I want to stay this long in space, and you companies go out and build it, and we'll pay you for that. What Elon Musk is doing is taking technology that exists today, and he is packaging it in his own product to allow him to sell this capability to people who can afford to pay, which isn't many, because he's going to charge $20 or $30 million for a seat. He has a contract with NASA to provide cargo, which he does, but all of his development, well, 85% of his development, and Boeing's commercial development, and Sierra Nevada's commercial development, and Blue Origin's personal development was done with NASA money. So that's not their own money. When you're a commercial company, a private company, you find investors to invest in your product, and then you put your product out. And how much time you spend developing that product and testing it, and if it's something that could kill you, ensuring safety in it, has to be balanced against when you need to see a return on your investment, right? That's the way business works. I mean, I'm in the government, I don't know, but that's the way business works. Well, that's what Elon Musk has done. He has developed a capability, he has packaged hardware that is already existing, he's done a very efficient job of it, but he's done it with 85% of money coming from NASA, but he's developed what he wanted. It does not meet NASA's particular goals, it meets his goals. Now he's going to sell that capability back to the government, and then the government's going to pay him if it goes wrong. Who doesn't want that deal? You know, that's a great deal. So commercial companies are, I think, a good way to provide something that is doable, that's done, you know, that has been done before, but they are not going to do exploration missions, because the amount of money it takes to do a Mars exploration is substantial. It's huge. Where is the return on his investment for that? Unless he can afford to make a generational investment in that, he can't do it. I mean, he says he's going to go to Mars, and we'll see, but you watch how much the government pays him to do it.
Hvala, svima još jednom.
Is it possible to parachute down from the station, and why not?
Only in a movie is it possible to parachute. And the way they do that in the Star Trek movie, you know, I'm not quite sure how that works, because there's atmosphere, and you are moving at a very high speed. And so high speed coming into the atmosphere is like if you took your hand and smashed it into a pool of water. You know, it hurts. Well, yeah, it's going to burn you. I mean, it's heat. The smaller you are, the less heat you're going to generate, but you still need to be able to deflect that heat. You know, you could do it with a balloon or one of those big sail kind of things, you know, that surfs in. You know, the science fiction stories, I like those, that let you parachute down from space. The guys that did it in the balloon, they never really got out of the atmosphere, and they had no speed. The more speed you have, the more friction in entering the atmosphere, the hotter you get. So if you have no speed, then you don't get really hot. But you can't actually stop, you know, because of inertia and gravitational forces. You can't really stop it. So don't do that either. Okay, thank you very much.
Hvala svima.